this must equal this. So 5 over Q equals Q over 5. Since my Q is kind of weird, so let me put X. It's the same thing. You can continue with Q if that's what you want. Can anyone tell us what how we proceed here? So like, let's say, Brian, I haven't heard from you. Ari, I haven't heard from you. Rachel, I haven't heard from you. So how do we proceed? So Brian, Ari, and Rachel, are you here?
Would you cross multiply?
Thank you very much. Who said that?
Oh, Rachel.
Thank you. Of course, it's a proportion. Excellent. A proportion means A over B equals C over D and nothing else. And then AD equals BC. Great job. Thank you. So 5 times 5 is 25. X times X is X squared.
Professor Lee?
Yes, I'm ready.
My computer, like, audio cut out for, like, the last bit. Was there anything? I'll look at the recording, but was there anything that I needed for, like, the upload?
No, not yet. In a minute. Thank you.
Thank you.
Thank you. You didn't miss anything yet. Okay. So how many solutions we get here and what type of equation is it? Brian, are you with us?
Yeah, I'm here.
Oh. No, I said Brian. So what type of equation is it? It is important to identify it correctly so we know how to solve it correctly. Ari, what do you think? What type of equation is this?
Is it quadratic?
Thank you very much. How many solutions will a quadratic equation have? Always.
2.
Excellent. How do I get them? Great job. How do we get those solutions?
Would it be -5 and 5?
That's it. So we take the square root. Remember, the square root of 25 is not plus or minus 5. Plus or minus come from this side. Good. But we cannot have a negative quantity. So both solutions work, but we will only consider for our situation x equals 5 units. In order to find the equilibrium point, we already have x, but we have to find the revenue or the plug-in any of the two functions, either in demand or supply. It doesn't matter. So the equilibrium point, when I plug in 5 for Q or X, it doesn't matter. What do I get for the price?
1.
1. So the equilibrium point is a point. It must have X, comma, Y. And it says price in hundreds of dollars. So you can put 100 if that's what you want. Okay? So, and the quantity in thousands. So this is 5,000, comma, 100. Okay?
Is there any way, did we find the one, I'm sorry, did we find the one without the graph, or did we find it with the?
We found
I
the
mean
5.
The, Y. Yeah, we found the 5, but I mean the 1. Do we just look at the graph? Or?
No, we just plug it in any of the two. It has to be the same value here.
Oh.
So we plugged it in either in this 5 over 5 or 5 over 5.
Oh, I see what you mean. Just plug it back in the equation.
Right,
Thank
because
you.
this is, yes, because this is a system of two equations. And once we get the point of intersection, we can go back and plug in that value at that x value in any of the two. It has to be the same. Okay, so everything, let me see, the price of admission. Okay, number of tickets sold is inversely proportional. Yes, I want to talk about that. And then we'll come back to the problem. So, direct and inverse proportional. If we're told that y varies directly as x, we have to write y equals k times x. K is a constant of proportionality. An example, both are increasing or both are decreasing. Okay, so this is something like this. As x increases, y increases. So they vary directly. The increase of one triggers the increase of the other. The other possibility, there is a third one, but your book presents only two, so we'll stick with that. Y varies inversely as x. Then y will be k, the same constant, over x. And what will happen here is something like this. As you see, as x increases, y decreases. They don't vary directly, they vary inversely. Okay? When one increases, the other one decreases. When one increases, the other one decreases. Same thing here. I mean, they go in the same direction, but here inverse. So now we're ready to work on an example like this. So the price of admission. And I am on page 5. Okay, the number of tickets sold for a Humane Society fundraiser is inversely proportional to the price of a ticket P. So number inversely directly as P. So 85, number inversely proportional with the price. Number, constant, price. As this number goes up, this number has to go down. Knowing that, let's see what they're giving us. If 175 tickets can be sold for $20, how many tickets will be sold if the price is 25? So we are given 175 and 20. When we sell 125, the price is 20. Or the price of 20, we sell 175. Why is this information given to us?
To help us find what the price would be for the other one. So basically, so we can find K.
To help us find K. Good. So 175 equals
and then
K.
Once we find K, we can use that to find the
exactly.
price of 25.
We will put it back in. We will write the exact relationship, and then we'll answer the question. How do we find K?
Do you multiply N and P?
Yes. Multiply 175 by 2. And what do we get? 0 and 1, 5 and 1, and I think I got 3,500. Correct me if I'm wrong at any point in time. I'm lazy with the calculator. I'd rather calculate. Okay, so then the equation then is N equals 3,500 divided by P. This is the equation that will enable us to determine the number of tickets we can sell if the price goes from 20 to 25. So can anyone give us the number? Which is 3,500 divided by 25. How much? How many tickets?
140.
Thank you very much. I trust you. So at any point in time, and I still see in your work that you are not putting the measurement unit, which is dollars. Here there is no measurement unit, that's why we left it open. And you don't, not everyone puts the measurement unit everywhere, as I'm kindly asking you to, please. Okay, I think we can put this chapter to rest. Let me look again just to make sure there is nothing else that we should address. Okay. Yeah, this is just plugging in.
Jalen had a question in the chat.
Yes, thank you. What was the question?
I think he wanted to see the inverse graph again. It
Yes.
just came up on my phone real quick.
Yes, of course, right here. These are just examples. Is this okay? So this is a little table just for you to understand the relationship. This is for direct and this is for inverse. Is this okay, everyone?
Yes, ma'am.
Okay, perfect. So finally, let's start chapter 1. So I don't want to forget, for Monday, all my lab math from entire chapter R has to be finished with at least 60% each assignment. Please. I hope you're not going to work for 60% in my class. That's my hope. Please don't work for 60%. That's not a reasonable grade. It's a passing.
Excuse me.
Yes, go ahead.
I know we're starting chapter 1, so will we be doing chapter 1 on the My Math Lab by Monday too?
Depends on what I cover tonight.
Okay.
Professor, what are we uploading today for the class?
What I would like you to upload, it's a good idea to stop and upload. So I've noticed that some of you have difficulties with adding fractions. So that really broke my heart. So we're going to upload something in chapter 1 in a minute.
Okay.
Thank you. Okay, so we're ready to finally start our calculus class. So this is it. So we start chapter 1, and in chapter 1 we are going to discuss limits, continuity. It's a big chapter. It's entitled differentiation, but till we get there, it will take some time. So the chapter 1 is differentiation. I have a lot to explain before that. Okay, so the first item that we need to look at is section 1.1, which is about limits. And what is this? What is a limit? Okay, so let's take a look at this function. And this is the coordinate system, of course. And I'm going to pick a number here. Can you give me a number, any number you want?
6.
6 is good, 5 is good, it doesn't matter. And let's say there is a number here corresponding to this point. What would you say it is? For the sake of the explanation or the argument here.
5.
5 it is. Awesome. So when we look at this function, tell me if you understand the following concept. As I come from the right-hand side, I approach 6 from the right-hand side. What does that mean? Not with numbers like 100 and 1500, but something like, I don't know, 7, 6.5, 6.3. As I come closer and closer to 6, follow this graph. The function values get closer and closer to which value?
5.
That's it. Now let's talk about the same concept from the left-hand side. As imagine that we approach 6 from the left-hand side. The function values will approach which number?
6? Or no?
Function values. The function values are read only on this axis. The x values are read only on this axis.
Would it be 5 again?
It will be 5 again. Now, stay with me. So here's the same function. The same 6 you gave me, and the same 5 you gave me. And this is our f of x. As x approaches 6 from the right, the function values approach. Approach does not mean equal. Okay? So as x approaches, not equal 6, as x approaches 6 from the right, the function values approach which number?
5.
That's it. As x approaches, thank you, as x approaches 6 from the left-hand side, the function values approach which number?
5.
Good. So no, go ahead.
Never mind. I think I messed it.
So it doesn't matter whether the function is defined at this point. When we say approach or approaches, we really mean it's a tendency, right? It tends to, it gets closer to, not equal to. So it doesn't matter whether the function is defined at this point, the point exists or it does not. How do we write this concept? It's a sophisticated concept, and we have a specific way of writing this for this as well as for this. And notice that I said from the left and then from the right, and then from the left. And also another concept, I can approach simultaneously. We can find x values that simultaneously on both sides approach 6, and still this works. It approach the numbers, the function values approach the same number. So we have 3 things here. It's called the limit. It's written LIM. As x approaches 6 from the right. From the right means with values higher than 6 of f of x equals 5. I want you to understand that this is an operator similar to the square root of a function, or the function squared, or natural log of the function. All these do something to the function.